tree and it is used to solve range minimum queries. It's a very important topic in competitive programming as well. So if you are solving long challenge or questions on code forces, you will definitely find a lot of questions on range queries. For example, you want to find out the maximum element in a range L2R, and then you want to perform some updates on the array. Okay, so it's going to be a class on divide and conquer in which you will learn to build a data structure that is based upon this concept. Okay, so Apar Bhaiya, who is there in the video, you can see he is going to take this session, and I'm Pratik
Hello,
Bhaiya. So I'm just here to introduce Apar with you guys and say hello to everyone. So I hope you will find this session quite useful uh, today. Okay. So I will now hand it over to Apar. And in the meanwhile, if you have any doubts, if you want to do a shout out or you want to say a hi, you can just post in the comments below. Okay. So yeah, roughly it will be around 2 hours. It will be you will also get the certificate at the end of the session. So you have to watch it throughout, and we will also mail you some problems that you can solve after attending the session. Okay, so we'll make a list of problems that you can solve, and we will share it with you guys on email. Okay, so everyone ready to start the session? Okay. Hello Samir, hello Aman, Chatakshi, Anuj, Sumitra. Okay, so guys, uh, yeah, so I'm going, and Apar Bhaiya is going to teach you segment trees today. So all the best for the session.
hello everyone. Myself Apaar, as Pratibhi has already introduced me. Today, I'll continue from the basics of segment tree, and I'll try my best to make you understand how does a advanced data structure that is segment tree works in the given time, right? Okay, so I hope all of you are ready with this. Right. So, is my screen visible to you all? Yes. Okay, guys. So let us begin with today's class of segmentary. Today's workshop for segmentary, right? Okay. So, guys, what is a segmentary? It's a tree-type data structure, and it contains the answers for certain segments of array, right? Let us see this structure, how it is built, and how to query and how to update on segmentary. And also, if the time permits, I will try to code it down for all of you, right? Okay. So let's say we have an array. Initially we'll have an array, and on that array we'll try to build a segment tree. Then further we'll see how to build that same segment tree on arrays of different sizes, right? So let me take an array. Right. So segment tree here has a binary type of a structure. Binary tree type of a structure. You'll come to know about it. Right. So what I'll do is let me index them. Right. So here I have an array, and array's size is 8. Okay. So we have indexed it from 0 to 7. Now what we'll do is we'll make a binary tree over this array and understand that how that binary tree helps us to make this segment. Okay. Right. So making a tree over this, initially we'll have leaf nodes. Right. Now every node will have two children, that is the left child and the right child, and except the leaf nodes, right? Because leaf nodes does not have any child with the definition. Right. So again, moving one step above, right? So this is the root of the tree, the topmost node, right? Okay. So guys, every node in the okay. First of all, let us just try to understand this structure and see some properties of this structure, right? This is a binary tree structure because every node has two values. I hope this is clear to you all. Secondly, every node here will contain answer for a particular range, right? So let us see what ranges that does this node contains. Okay, right. So let's start with the leaf node, the node at the lowest level. So the leaf node will contain the answers for values from particular index to that particular index only, right? Basically, what I'm saying is, keep for a node, that node covers how much area of the array, right? Let us see this. So this is the leaf node. It covers answer from 0 to 0, right? 1 to 1, 2 to 2. I'll build a segment tree for range some query and I'll explain it to you with an example also. Just try to understand what I'm trying to explain here, right? 3, 4, 5, 6 and 7. Basically every node contains the answer for a particular range, that is L to R. Okay, I've written in this way, L to R, left to right. So guys, now we can easily see that for non-leaf nodes, okay, let me write it over here. For non-leaf nodes, what will be my left to right, that is L to R. Let's say I have a non-leaf node and it has two child because it's a non-leaf node, right? So let's say this was L1 to R1. That means this node was covering the answer from L1 to R1, and this node R1, right? And this node covers the answer from L2 to R2, right? So what will this non-leaf node cover the answer from? That is, what will be its L to R? As we can easily see, what will be the range of this non-leaf node? It will be the leftmost value of the left child of this node, and its right value will be the rightmost value of the right child of this node, right? So try to imagine here, or you don't need to imagine, you can just directly see that for this node will cover the answer from 0 of the array to 1, index 0 to index 1, right? So index 0 to index 1. This will cover the answer from index 2 to index 3. This will cover the answer from index 4 to index 5. And this will cover the answer from index 6 to index 7. Right? I'm just giving a 10-second break right now for you to realize this. How did I write its ranges? 0 to 1, 2 to 3, 4 to 5, and 6 to 7. So till that time, let me see any chats. Right, okay. L1 to R2. Okay. So should I continue further? Anyone of you has doubt till now? So guys, for this node, what will be the range that this node covers in a array? 0 to 3, right? And this node covers how much? 4 to 7, right? Finally, coming on the topmost node, that is the root node of the tree. So the root node of the tree will cover the answer from 0 to 7, right? So guys, again summarizing it, for leaf nodes, what does a leaf node contain? Answer from index to a particular index. I'll write answers for each of them, don't worry about that. And what does a non-leaf node contain the answer from? The non-leaf node contains the answer from its leftmost value, left child's leftmost value, and the right child's rightmost value, right? That is L1 to R2. Okay, so I hope you got this left to right thing till now. Let's continue further. Okay, let me check any doubts till now. Clear, okay. So guys, moving further, what we have here is we have a binary tree and we have marked some indexes, and the indexes are actually the segments. L2R is a segment, and particular node has answers for the segment from L to I, right? So let's make a tree in which a node contains answer for a summation value. Node contains answer for let's say, let me write it like this: L to R and summation of AI. I equals to L to R summation AI. Okay. So guys, let's fill this segment tree node. First of all, let us write some random values in the array. Okay. So let's say this is 1, 5, 1, 2, 2, 3, 5, and 7. Let's take some random values, right? So guys, what will be the answer for these leaf nodes? It will be the same as the index, right? Because it contains the summation of those nodes, right? Now guys, for the leaf node, it's pretty clear to us that the answer will be the same as the index of the array, right? Now tell me about non-leaf nodes. For non-leaf nodes, what will be the value that will be at a particular node? Think about it and tell me. So every non-leaf node contains the answer from its left child's leftmost value to the right child's rightmost value. And we already know that the left child's leftmost value, the left child's segment, that is L1 to R1, and the right child segment, that is L2 to R2, both of these segments are actually disjoint, right? Because it's pretty clear, we can easily see in the structure above that these are disjoint. What does disjoint mean? That L1 and L1 R1 and L2 R2 does not overlap, right? That means they're disjoint. So basically we can easily see that they do not overlap, right? So guys, what will be the answer for a non-leaf node? For a non-leaf node, what will be the answer? It will be the value of left child plus the value of right child, right? So filling up for these values for the other nodes, for the node 0 that contains the answer from 0 to 1, what we have, the summation of the leftmost value plus the summation of the rightmost value, that is 6, right? Okay, let me fill this with yellow. 6. Again, for this node, left plus right is 3. For this node, left plus right is 5. For this node, left plus right is 12, right? Okay. Again, moving up one step above, for this node, guys, what will be the answer? It will be 6 plus 3, that is 9, right? Left plus right, again left child plus right child, because guys, left child and right child covers the whole range of the current node, right? So for this we have 17 over here, and again 9 plus 17 is 26, right? 9 from here and 17 from the right subtree. I hope this much is clear to you. So basically every node contains the summation of ranges for a particular segment, right? Okay, so moving on forward. Okay guys, I will also code it after explaining this. I'll code this in Sublime Text, and then also you can confirm your doubts, right? So don't worry about the code. I'll code it and also I'll share it with you. Okay, right? So let me check some doubts. Okay. I hope this much is clear to you, to everyone. So guys, now let's try to understand that what will be the space complexity for the segment tree. Like how many nodes does a segment tree contain, right? Okay, so guys, for this I have made a pretty easy example, because here I have length of array equals to 8, right? So we can easily see, let me raise this, because actually I have to explain you on this structure only, so I have to erase it again and again, right? So guys, how many nodes does the last level have? It has how many nodes? 8. How many nodes does the one level above has? 8 by 2, right? Because every two nodes combine to one parent. So 4, 2 and 1, there will be one root node. So guys, if I try to add this, it forms a GP, right? So if I try to add this, total how many nodes will I have? If the last level of the segment tree has n nodes, then I'll have n plus 2, n plus 4, right, n plus 8 and so on. So this is actually n 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, so on. How much till how much this will go series? Until n by that value k is equals to 1, right? Otherwise it will be 0. So basically what will be the summation for these nodes? Guys, we can easily see that this number if represented in binary is of the form which type of 1 plus 2 plus 4 plus 8, right? So what is this number? These numbers which contain all set bits are of the form 2 की power some m minus 1, right? So if a number contains all set bits, this number, it is of the form 2 की power m minus 1, right? So if a number is of a form 2 की power m minus 1, now we just need to know what is m over here, right? For 8 we got m equals to how much? Okay, let me write it here only, just erase this. Right, so for 8, let's say n was 8, then what will be m value over here? M will be equal to log of 8, log base 2 8, right? Because we can easily see the height of this segment tree, this will be how much? Log of n, because it's a binary tree and every two nodes are combining into one other node, right? Because at every step I am reducing my nodes. Or do you want a proof of this, or are you okay with this? Okay, see, the root node contain one nodes, right? The next level will contain two nodes, the next level will contain four nodes, 8, 16, 32. And what will be the length of this? It will go until the value is less than n, right? So what will be the summation of all these nodes? It will be some number 2 की power m minus 1, right? I hope you got this. Now what is m over here? M is basically log of n, okay? Because log base n is the height of the tree, right? So 1 2 3, here we have how much m, okay, here we have, it will be seal of log base 2 8. I'll explain it to you why, right? So here we have m equals to how much? 4, right? Because guys, 8 plus 4 plus 2 plus 1 equals to how much? 15. So here what we'll have, m equals to seal of log base 2n. Okay, so as assumption that m is log base 2n is wrong. It is how much? Seal value of log base 2n. Okay, and I'll also give you a proof of this, don't worry, right? So if m is how much? Log base 2n seal, then what are the total nodes for array with length n? It is 2 to the power 4 minus 1. I hope you got this. Okay, so guys, let's say if my array contains 16 nodes, then I'll have 16 nodes, then I'll have how much? 16 leaf values, and 8 one level above, then 4, then 2, then 1. Right? It will be 16 plus 8 plus 4 plus 2 plus 1. That will be how much? 31. Right? So basically, what I have here is, again, I'm doing everything in front of you. Just try to go with me, like go with the flow. Okay. So again, we get this is log base 2n, right, plus 1. Right? So these are the nodes in a segment tree. Right? Okay. Now, guys, moving on forward. Now what we'll do is we'll try to understand. Just let me raise this. I'll write a code for this and I'll try to run that code for you. Don't worry. Right? Okay. Right. So now let's try to understand that for now, till now, I am taking that whether n is some 2 ki power, right? Basically, some 2 ki power m. If n is some 2 ki power m, then it's pretty easy that we'll form a normal binary tree. But guys, imagine that let's take n as 6. That means that my array contains how many values? 6 values, right? And I have to build a segment tree on this 6 values. So guys, if I try to build a binary tree on this, I'll get stuck. Right? Now I can combine these two, but if I have to combine these two, I can't take it this way, right? This won't form a good binary tree. So for this, what I need to do is, what can we do this for to when we have a length of 6? Again, it's very easy that we can make a complete binary tree, or we can make a full binary tree, right? How? If the length of array is 6, it doesn't matter, just take the next power of 2. What is the next power of 2? It is 8, right? So make a segment tree for array of length 8, right? Make a segment tree for array of length 8. Okay. And now what will happen? These nodes, this node, this will contain how much? 0. Why? Because these are out of range values, right? So what I have done here is I have actually built a segment tree on the range that is next power of 2. So if it is 5, then also I need to build a segment tree on 8 length. If it is 4, then I'll build it on 4 only, right? If it is 7, then also I'll take the segment tree of length 8, right? Okay. So guys, just let me quickly go over this. So if I want to make a summation tree, and let's say these were the values 1, 2, 3, 4, 5, then again 0, 1, 2, 3, 4, 5, and here what I'll have here is 0, 0. Why? Because it is out of range values. So I have to keep such values over here such that it doesn't affect my answer when I build the answer for this node, right? Because if it will affect my answer, then the segment tree will contain wrong values, right? Okay, so here it is 1 plus how much? I'm making a summation tree. Okay, 2 plus 3 is 5, 4 plus 5 is 9, 0 plus 0 is 0, and now here I have is 9 plus 0, that is 9, and here I have is 1 plus 5, that is 6, and here I have is 9 plus 6, that is 15, right? So if you had doubt about this ki I can't make a binary tree on numbers that are not powers of 2, then what we can do is we can make a binary tree on the next power of 2 of that number. If I have 11 nodes in my n, that is the length of the array, then I'll make a binary tree which has how many? 16 leaf nodes, and rest 5 nodes will contain the value 0 because they are out of range values, right? Okay, so generalizing this, let me just generalize it. So if I try to generalize this, what I'll get is summation of n equals to how much? 2 weeks log 2n ceil plus 1 and minus 1, right? So basically what is my m over here? Log base 2n plus 1. Okay, right. Now let me just manipulate this formula to um, make an upper bound for this. Like what will be an upper bound of number of nodes if the length of array is 9, so that when we'll code it, we'll just take that many nodes. Okay, let me just manipulate it. So this Sn, it will be less than 2 into 2 log base 2n, right? Why? Because I've taken this plus 1 as 2 itself, and I've just removed the upper minus 1. Okay, let me just space it, otherwise you'll get confused. So this was my first, and let me write it like this. It is less than 2 into 2 to the ceil log. I'm just giving a mathematical explanation on this, nothing else, right? So this will be less than this, right? Again, this will be equal to how much? 4 into log base. Okay, this ceil is going further above, right? So just let me just erase this so that you don't get confused again. Let me make a line. Yeah, so this is equals to how much? 4 into 2 log base 2n, right, minus 1. Like what I have done over is I converted this plus 1 to this 2, and then what I have done is I have taken minus 1 over here and written one more 2. So the total is 4, 2 into 2. Okay, right. I just want to generalize one thing over here that you'll come to understand, that you will know like why am I doing so, right? So it is minus 1 over here, right? So this value is less than equal to how much? 4 into 2 base. Now I have taken the floor function, right? So what does this value means? Log base 2n. I can write it as like this. It is less than equal to 4 into n, right? Because 2 ki power log base 2n is equals to how much? N, right? We all know this much maths, right? Okay. So what I have got here is that summation of n, that is total nodes in a segment tree, this is always less than equal to which value? 4 into n. For any node, for any number n, you can try this. 1, 2, 3, 4, for any number n. Okay, I just generalize this. So basically, for any number n, the total nodes in the segment tree won't go more than 4 into n. Okay, right. Right. So guys, what will be the space complexity of my segment tree? If I try to build a segment tree, then how many nodes will I need? I need 4 into n nodes. So this is my space complexity for a segment tree. If I try to build a segment tree on array of length n. Okay, I hope this much is clear to you all. Right. Now moving forward, do I need to check the doubts? Okay. Right. So this was my original segment tree over here, and this is the proof of the space complexity of the segment tree, right? Okay, so guys, when I try to build a segment tree, so okay, let's talk about prerequisites of this segment tree, like what all you should know before going into the code of segment tree, right? So prerequisites to code, because prerequisites to understanding segment tree is nothing, right? Because it's just a matter of like we just have to understand the logic. Why are we building segment tree and what is happening over here, right? Which I guess you all have understood it. Prerequisites before I code is first is recursion, because through recursion I'll build a binary tree, right? And what is a second prerequisite? Nothing, just recursion. Okay, because I'll build a binary tree through the recursion, right? Okay, so guys, right. So I hope the space complexity is clear to you all. How we got 4 into n, right? So let me raise this. So what is m over here? M over here is C log n plus 1. Okay, right. So now let's try to understand query part and update part. Like what's the basic use of segment tree, right? It helps in query. It answers my query in login and it updates some value also in login, right? So guys, let's say I have a question that tell me the summation of range L to R, and there are various queries. Tell me the summation of range from L to R again and again, right? There are various queries. Let's say there are m queries and m is 10 to the power 5. Okay. So what are the ways in which I can tackle this question? The first way can be to calculate prefix array, right? You can calculate prefix array, and for a range from L to R, what you can do is calculate prefix of R minus prefix of L minus 1. I hope you all are well aware of this, because if you are studying about segment tree, then you should know about some small data structures. Wैसे not a small data structure, but some small tricks, right? So this is the first way we can do this. But what's the disadvantage of using prefix array, of calculating prefixes? We cannot update, right? So what's the disadvantage over here? Update is not possible, because if we have to update it, then I have to convert the prefix array again back to the normal array, and I have to update the value of that node and again calculate the prefix, right? So I cannot update in limited time, right? I need much time to update, basically on. I need on to update in prefix array, right? But my guys, segment tree will complete my update in how much? Log of n time, right? We'll see how. Okay. So now let's try to understand the query part of the segment tree. Let's say I have a query that tell me the answer, the summation from 2 to 5. Okay, tell me the summation of the value in the array from index 2 to index 5, right? Okay, let me just check if there are some. Okay, right. So okay, moving forward, let's understand how to query on segment tree. So basically what I have here is, when I have to query from 2 to 5, that is from a range 2 to 5, if I have to query, guys, tell me, I'll start my query from the root. Okay, go with me and I'll go slow over this for you to understand. Okay, and I'll dry run for two to three queries, like how I am querying and what is the time complexity of the query. Okay, right. So this is my first example, 2 to 5. So currently I am on the root node. Root node contains the answer from 0 to 7. Let me raise this. I hope this is clear to you all. Okay. So the root node contains my answer from 0 to 7. And but my query is how much? 2 to 5. So 0 is over here on the number line and 7 is here. But I need the answer from 2 to 5. Right? So guys, do I need the answer? Do I need this value 26? I don't need that value 26. Why? Because this value 26 contains the answer from 2 to 5, but it also contains additional information from 0 to 1 and 6 to 7. Right? Digest it, try to understand this, then I'll move forward. So I do not need this, right? The answer from 0 to 7. Right? Okay. Right. So let's move forward. Now guys, I do not need the answer for the root node. Now I'll try to ask the answer from the left subtree and I'll try to ask the answer from the right subtree. Okay. Now currently let's move on the left subtree first. Then I will do the same for the right subtree. So guys, here I am on a node. Which node? 0 to 3, right? And my range is how much? 2 to 5. So if I write 2 to 5, it will go from here to here, right? Basically here it's a partial overlap, right? So I also do not want the answers 9. Why? Because this 9 contains the value from 0 to 3, but I need the answer from 2 to 5, right? So what are the extra values in this node? That is 0 to 1 extra value. And what are the values that this node does not contain? It does not contain the answer from 4 to 5, right? So basically I won't take this 9, and I'll again, what I'll do is I'll again recur for the left subtree and the right subtree. Here I don't need the value of this node. Just tell me the value in the left subtree, like what is the value that I get from the left subtree and what is the value I get from the right subtree. Okay, right. So guys, now moving on to this example, 0 comma 0. Currently I'm on a node 0 comma 0. Don't worry, just listen and then we'll generalize this everything. Okay, right. So guys, 0 comma 1 is disjoint from 2 comma 5. I want the answer from 2 comma 5, 2 comma 5, but I am currently standing on 0 comma 1, right? That this node contains the answer from 0 to 1. So if this node contains the answer from 0 to 1, do I need its answer? No, right? Because it's completely disjoint. And guys, secondly, the most important part that you need to understand is ki, do I need to recur it for the further trees? Like, do I need to ask for the answer for further trees from the left subtree of 0 comma 1, this node, and the right subtree of this node? Do I need it? Think about it. If guys, this node is containing the answer from 0 comma 1 and it is disjoint, so its subtree will contain the answer from 0 comma 1 itself, right? And if I don't need the answer from this range, so why would I go to the subtree? Because the subtree itself won't contain the answer, right? So basically I won't recur for the down parts, right? So what I'll return from here is I'll return an answer that does not affect my answer because it was a non-overlapping range, completely disjoint range. So 0 comma 1 was completely disjoint from 2 comma 5. So I'll return 0 from here, that I need 0 from here, right? That I does not need any answer from this subtree, from the subtree of this node. I hope this part is clear to you all. I'll just give a 15-second break and you all need to think about it, what I have just told you. Why don't we need to go to the subtree of a node which contains the answer for a disjoint interval from the current query? Okay, I hope you got this. Now let's move forward further. So basically, let me write it over here in a different pen. This node returns how much? 0. Okay. So guys, now we are on this node 2 comma 3. Now guys, 2 comma 3 lies completely inside how much? 2 comma 5. So 2 comma 3 lies completely inside the range 2 comma 5. So I have got a segment that lies completely inside my query range. So I will need the answer for this segment, right? Because it lies completely inside my query range, right? So what will I return from here is I return 3. Again, it's very important to understand that why I'm not going in the subtree of this node. I'm not going in the subtree of this node because I have the answer for whole of the subtree over here, right? And when I'm trying to return a node for a particular subtree, then why would I go to the for further depths in the tree, right? Because I already have the answer for that range. So basically, in 2 comma 5, 2 comma 3 is covered, right? Now I'll return, and here the answer that will be written is 3. Here the answer that will be written is how much? 0 from the left subtree and 3 from the right subtree. So this tree will give me how much? 3 over here, right? Now coming on the right hand side, again I'll perform the same operations. If I am at node 4 comma 7, so guys, again 4 comma 7 and 2 comma 5, Do I need the answer for this node? No, I do not need the answer for this node. Does 4 comma 7, is it completely disjoint? It is not completely disjoint. So I need to divide it into two parts, and I'll ask here, tell me the answer from the left subtree and tell me the answer from the right subtree, because it is neither completely overlapping and it is neither completely disjoint. It's somewhere in the middle, right? 2 5 and 4 7, it contains the value from 4 to 5. So I need to go in the subtree. Okay, so let's go in these subtrees. Right, currently let's say I'm standing over here. So guys, do I need the answer from 4 comma 5? Do I need the answer from this node value 4 comma 5? Yes. Why? Because again, 2 to 5, 4 and 5 completely overlapping, right? So if it is completely overlapping, I don't need to go in the subtree of this, and I'll return the answer that this node contains. So let's just switch the pen. This will give me how much? 5. And this will give me how much? Okay, this I wrote in blue, so it's 3 over here. And don't get confused, guys, there will be many other things that I'll write over this, right? So it will be better if you follow a particular order, right? Okay, so this returns 3. And again, 6 comma 7, from 2 to 5 it is completely disjoint. 6 comma 7, so what will this return? It will return 0 because it's completely disjoint, right? So again, this node, what will this node return? The node 4 to 7, it has asked the answer from the left subtree, and the left subtree gave the answer 3. It has asked the answer from the right subtree, and the right subtree gave the answer 0. So the total answer will be 3 plus 0. How much? Okay, yeah, it is 5 over here. It returns 5, not 3. My bad. 5 0, right? So the left subtree gives me 5 and the right subtree gives me 0, so it will return 5, right? And guys, finally, what will the root node return? It will return the answer that it got from the left subtree, and it will return the answer that it got from the right subtree. So from the left it got 3 and from the right it got 5, so 3 plus 5 is 8, right? So guys, for the query from 2 to 5, what we have is 1 plus 2 plus 2 plus 3 is 8. I hope I have made clear the query part to you all, right? Just I'll give you a 10-second break and then you can easily go over this. Like what have we done over here? What are the different ranges? First of all, there are 3 types of ranges. I'll cover that, don't worry. And when I code it also, I'll try to cover that again, right? Okay. Yeah, left should return 5. Sorry, my bad. Actually it was 5 only, and I wrote something else, right? Okay, let's move forward then. 8. Okay. Now I won't run the whole code again and again for a query. Now what we'll do is we'll just discuss this complexity. Okay. So from 2 to 5, how many nodes did I travel? I traveled 1, 2, 3, 4, 5, 6, 7, and 7 nodes. Guys, I traveled 7 nodes for the query 2 to 5. And if I simply ran from 2 to 5, if I ran a pointer starting from 2 till 5 and take the summation of those nodes, what I'll get is only that loop will end in 5 time only. But you can see that for a segment tree, I'm going over 7 other nodes. Here the complexity is more than a simple loop, right? Why is this happening? Because guys, current range is very small, right? If the current range is very small, then this value of segment tree, the query from segment tree, may go more than the normal queries. But guys, imagine that you have a range of 10 to the power 5. Then imagine that the top node will contain the range 10 to the power 5, and the lower left node and the right node will contain the range 10 to the power 4, 5 into 10 to the power 4, right? And this also 5 into 10 to the power 4. So imagine if we have ranges that are really big. On those ranges also, the segment tree will perform operations, but those operations won't increase the value of range, right? Because those ranges are too big, the value of n is too big. Okay, right. So the main thing that I wanted to tell you is that a segment tree performs query operation in log n, but we have seen that it is not exactly log n, log of range, it is not log n, right? It is not log n. But guys, again, what I'll talk about here is I'll talk about the expected value. You know the expected value, right? So what is the expected value of a query? It's very simple. The expected value of a query will be how much? See, okay, now let's take a range query, and the query is from how much? 2 to 7. 0 to 7. The query is that tell me the answer from 0 to 7. Okay, let me erase all these. So try to run it yourself first. Where we need to go for the query from 0 to 7. Let's start from the root node. So the root node contains the range 0 to 7, and my query is also 0 to 7. We have found a complete overlap. So guys, if we have found a complete overlap, we don't go in the subtree. We return the current value. So guys, what was the time complexity for the current query that is 0 to 7? It is O1 only, because we traveled only one node. We don't have to go in the left subtree and we don't have to go in the right subtree. It will return 26. Right? I hope you got me over here. Right? So basically, for some queries I have bigger values. For some queries I have very less values. You can see 0 to 1. Right? So what will be the expected value of a query? The expected value is the probability. Oh, okay, is the value. When we take the expected value, we all know about expected value, right? In probabilities. So what is the expected value? Expected value for a query operation in segment A is log of n. So guys, I hope it is clear to you all that it is not exactly log n, but it is expectedly log n. That is expectation value, because I have just dry run a range over here. Okay, right. So let's try to move forward. I hope query part is clear to you all. Okay, let me just run over one other query. Do you have any query that you want me to run over? Just give me a query. Anyone? Arpit, I hope I have made clear to you, right? Why why I can directly run over a loop, because it will cost me less, right? If it will cost me less, guys. So, but for greater values of n, it will not cost me less, right? For greater value of n, segment tree will cost me less. Guys, do you have any query regarding a query operation, or do you want me to run a query over some nodes? Okay, let me take an example myself. Let's say I want a query from 1 to 6. So guys, let's try to go over this segment tree. Firstly, I'll be on the root node. I'll try to left and right, because it's not completely and it's not disjoint. Again left and right, again left and right. This will return me 0. This will return me how much? 5. This will return me 5. For this node, I don't need to go in the left and right subtree, right? Why? Because it's completely overlapping. 2 to 3 is completely overlapping from 1 to 6. So this will return how much? 3. So basically 9 will return 5 plus 3 is 8. Right? Again, moving on to the right subtree. Again, this will return me 5 itself. I won't divide it further. And this subtree, the right subtree, will return me how much? I have to divide it further, because 6 to 7 is neither completely overlapping and it is neither disjoint, right? So this will give me 7. Oh, sorry, this will give me 0 and this will give me 5. So this will return 5, right? So 5 plus 5 is 10. This will return me 10 and this is returning me 8. So what will the root node return? The left plus right, that is 18. 8 plus 10. Try to run over a paper, right? Take paper and pen and all this, right? Try doing it yourself. It will be clear to you now. Okay. So let's generalize the query part. Guys, this is a segment tree of summation, right? We can also build a segment tree for maximum. right? That a node contains the range that is a maximum of a particular range, right? So okay, I'll build a node. Don't worry, I'll build over this only. I hope this is clear how we got 18 for a current range 1 to 6, right? Okay, so let's move forward. So in the query we have three types of operations. First is complete overlap, return the node value. Complete overlap of the range, it is return node value. The second is what? Partial overlap. If it is partial overlap, then what I need to do is ask for the answer from the left subtree, ask the answer from the right subtree, because it's partial, right? So what I'll return the answer that will be from the left subtree and the right subtree. Return answer from left subtree and plus right subtree if it is summation, right? And thirdly, what is no overlap? So if I have a range, I have a node that is of no overlap from the given range, what I need to return is I need to return 0 for that, because I don't want the answer, and neither will I go in the left subtree and the right subtree because it is completely disjoint. Okay, right. So I hope this was the toughest part of the segment tree. Otherwise, rest is pretty easy. It's really slightly tricky to understand what are these three nodes and from where am I getting the answer, why are all the nodes disjoint, right? Okay, now let's talk about update operation on segment tree. So I told you that update operations take log n steps only, right? Let us see how it takes log n steps. So guys, let me take an example. Let's say ki I have to update the value of uh, array 3. I have to convert it to how much? 10. Let's say I have to make 10. So basically initially I had 2 over here at the place of array 3, right? And I have to upgrade it to 10, right? So what will I do is I'll start from the root node. This index 3, it will be in the left subtree of the root node. I'll go in the left subtree of the root node because I don't have to make any changes on the right subtree, right? Because I only have to update a node that is the array at value 3. Okay, so I went to the right node. I'm currently over here at this node. Then I'll go in the right node. I'm currently over here. Now I have to go on the right node. Basically I'm just making a path from root to a particular node. So guys, the nodes that I have encountered on the path, this node, this node, this node, these are the ancestors of 3. Ancestors of 3, right? Ancestors of this leaf node that is pointing from 3 to 3, right? And I only need to make changes to these ancestor nodes only, right? Because all the other nodes does not require any change. So I have to update these nodes. Let me update these nodes. So I have reached over here. Let me replace this value by 10, 10 and 10. Now when I'll go back, what I need to do is I just have to update this node also, right? So what will be the answer at this node? It will be 1 plus 10, that is 11. Again I'll go back. What will be the answer at this node? It will be 11 plus 6, that is 17, right? And right, 11 and 10. And then I'll go back to the root node. Means I'm coming back from my recursion, right? First I went in the recursion, I'll reach the leaf node, I change the value, and then now I'm coming back and updating all the other nodes. Now what will be the change over here? It will be the left plus the right. That is how much? 34. So guys, after this update operation, we can easily see that we have updated the nodes that requires updation, right? We haven't updated the other nodes. We haven't updated this. We haven't updated this subtree. Why haven't we done this? Because 3 does not lie in this subtree. 3 does not lie in this subtree, right? I hope I have made it clear to you all. So we have updated some set of nodes, and you can see na, the segment tree contains the answer still for a particular segment even after updating the value at 3, right? So even after updating the value at 3, the segment tree contains the answer at this node, that is 10. See, 0 to 3 it is 17, right? 2 to 3 it is how much? 11. 4 to 7 it will be 17 because I haven't made a change. So 0 to 7 it is 34. I hope I have made it clear to you all how to update operation, right? How to do an update operation. Traverse from root, go to the leaf node, update the leaf node, traverse back to the leaf, and update all the nodes on the path. Okay. Now let's see how it takes login. So basically I am traveling from the root to a particular leaf. How many nodes will I encounter, guys? We have discussed about it, that how many nodes will we encounter on the path? Log n nodes, because its height is log n, and in every step I am coming one step down, right? The value m that I talked about, right? So let's take it log n only. Approximately log n it will be plus 1, just plus 1 it will be. So I am updating how many nodes in a per query? Only log n nodes. I'm not traversing to other nodes. So what is my what is my time complexity per query? It is O of log n, right, guys? Okay, guys, I just want to say one thing, that if it is not being clear to you right now, don't worry. See this recording again, or clear your because understanding part is quite easy and the coding part is tough, right? To understand the recursion that we write is a little tricky than to understand it on the graphical representation, right? So right, so if you don't if you're not getting it right now, please try to see it again and try to dry run it on pen and paper, because it's a advanced topic कि मतलब it's not कि यार आधा घंटा पढ़ो और आ गया है ना. You'll have to write, you have to think, you have to understand, right? So I hope I have made it clear to you that when you try to understand it by yourself, you can easily see, you can means you won't get stuck now. Okay, so try to understand, try to write it yourself also. Okay, now moving on further, we have discussed about building a segment tree, we have discussed about space complexity, time complexity, we have discussed about update operations, we have discussed about query operations, right? Now let's take different type of segment trees. Okay, now let us say कि I am making a segment tree that contains the maximum for a particular range L to R. So every segment will contain the maximum for its range. Okay, so again filling the leaf node, let's fill the leaf node. The leaf node will contain the answer, this will be 1 5 1 10 2 3 5 and 7, right? Now this node will contain the answer how much? Non-leaf node will contain what? You can think about it yourself now. It will contain maximum of the left subtree comma right subtree, because it's a maximum segment tree, right? It contains maximum for a particular range, right? So it is over 5 over here, and we have 10 over here, and we have 5 3 over here, and we have 7 over here. Again, maximum of the left and right, it is 10. It is how much? 7, and then it is 10, right? So basically I have constructed a segment tree which contains maximum in a particular range. Okay, so let me just check some doubts. Understood. Okay. Okay. Acha, Harsh asked that can we have a query from 0 to 9? See, if the length of the array is only 0 to 7, then we cannot query from 0 to 9, right? Okay, query part is clear. Okay, I understand how to code. Okay, right. Okay, I will slow down. Don't worry. When when I'll code it, I'll slow down. Okay, right. Okay. Okay, for the certificate, I'll give you a link to generate a certificate, and on from that link you can easily generate that certificate. Okay, right. हाँ भाई मिलेगा. Okay. right? So we have discussed pretty much about it. Now we can, by using the same query operations, we can have a maximum query of the maximum from a particular range. Now let's code it. Let's try to code segment tree. Okay, so this is my sublime, and in this I'll code segment tree from the beginning. Let's just include some file, and I'll code in C++, right? Okay, so guys, here I'll just add 2 lines in my code. Don't get confused. These 2 lines that I'm adding, you don't have to add in your code. Okay, it has nothing to do with the segment tree. These 4 lines, what these lines do, this takes the input from the input file input.txt. It reads the input here and it writes the output over here on the output.txt. Okay, so please don't get confused in this. It's nothing. It's just let me give you an example. Right. So let me write value of n, let's say 10, and it will read the input from input and write it to output. Okay, it has nothing to do with the segment tree. Okay, right. Now let's try to build a segment tree. Okay, let me write a structure segment tree. Okay, let's make a structure called segment tree so that we can use various segment trees. We can make array of segment trees, right? So I'll give you the best possible code of segment tree. Okay, and let's try to understand it. Okay, so what does a segment tree contain? It contains uh, basically it contains an array. That array will of the length 4 into n, right? Okay, so for that we need one more thing. Don't worry, we need one more thing over here, right? How to code it? Okay, so guys, how do we code it? This is the question. Okay, so first of all we have to make this binary tree. To make this binary tree, guys, let's give these nodes some values. Okay, okay, let me give these values. Let's say this is the node 0, this is the node 1, node 2, node 3, 4, 5. I'm just giving them numbers: 7, 8, 9, 10, 11, 12, 13, and 14. Right? So we have the nodes as 0 to 14. How many nodes? Total 15, as we discussed, to give power 4 minus 1. Right? I've given them values. So guys, just think कि for a particular node, we have its left child and we have its right child, right? And let's say its value is I. So what is the value of the left child? If you can generalize it, try to generalize it yourself. Just take a minute, don't worry. Okay, this workshop will end at 9 only. Well, I'll just code it in like half an hour and we'll finish it before 9. Okay, Abhishika, don't worry. And okay, so if we can generalize this, what I get is for a particular node value I, that is 0, what is the left subtree? 1 and 2. So basically it is 2 into I minus 2 into I plus 1 left, and what is the right? 2 into I plus 2. See, for 1 also what I get is 3 and 4, na? How I get it? It is 2 into 1 plus 1 and 2 into 1 plus 2. So we can generalize for all the nodes 2, 5 and 6, 5, 11 and 12, right? The left the left uh, the left node value is at which index? It is just 2 into I plus 1. and the right value is at which index? 2 into I plus 2 for every node. So whenever I'll go on with the recursion for these nodes, what I'll do is I'll just keep on the track of indexes. Where is my answer kept? Okay. Okay. So the coding part is a little tricky, guys, but it's not tough, right? After all, we also are humans, nah? So why won't we get it? Right. So basically, I'll have an array of length 4 into n, as I already proved you earlier. The array of the length 4 into n. Right. So let me index it. Right. Now, guys, what are these node values? At index 0, what I have is 10. At index 1, I have 10. At index 2, I have 7. At index 3, I have 5. Index 4, I have 10. Then 3, 7, 1, 5, 1, 10, 2, and continuing further, don't worry, 12, 13, and 14. So what are the values over here? At 11, I have 2, then 3, and 5, and 7. Basically, what I've done is, instead of just constructing a segment tree, I'll just go on this array, right? I'll just go on the array, right? So to understand, you can easily see this structure and see, I'll start with the root node. I'll try to query from the root node. Whenever I'll go on the left part of the root node, then at which index I will be standing? I will be standing at 2 into 0 plus 1. That will be 1. What is the right index? Here. Again, guys, if I want to go in the right index, in the right node of this node 2, that is this one, what I need is 2 into 2 plus 2. It will give me how much? 6. Right? So what I'll do is, when I'll write a recursion for this, I'll pass on the left and right index values. Right? So on those left and right index values, I'll be having a range, and what I'll also have these indexes. Okay, right? So basically, I have flattened my binary tree. Okay, I have currently flattened my binary tree, and that binary tree is actually I made it on the array, right? And on this array, I'll code down the segment tree. Okay, and don't worry, I'll print the segment tree for you also. So let's start structure segment tree, and let's say in this structure we have a vector. Okay, and let's name it st, that is segment tree. Okay, right? So for a let's say when I'll take a structure and I'll have to initialize that structure, so what should be the length of this segment tree vector? Okay, let me write a function called init, and I'll pass on n to it, right? So this function, init function, what it will do, it will resize the segment tree with 4 into n, and it will fill 0 initially. Okay, so I hope this is part is clear to you. It is actually initializing my segment tree, right? So okay, let me take an array. Let's take this array. It's of length 8 and 0, 5, 1, 10, 2, 3, 5, 7. 0, 5, 1, 10, 2, 3, 5, and 7. Okay, I'll make a segment tree for summation on this array. Okay, so basically I have input an n. Let's input that array. Okay, so I have inputted the array, and now I need to build a segment tree on this array, right? What I'll do is I'll just pass on this array to the segment tree, right? So let's take a segment tree and name it tree. This is a structure, right? Initially what we need to do is we need to initialize it by length of the array. So it will resize this vector segment tree that will contain the original values into 4 into n, right? Because I have already explained you that the space complexity will be 4 into n. This vector segment tree will contain the answer for a particular node. Okay, right? So after initialization, what I need to do is I need to build the segment tree. Okay, Now let's try to build the segment tree. Void build. So I'll start building from the root node, right? Imagine that the way I filled it. I'll start from the root node, I'll fill the leaf node first, and then I'll come back, right? So I hope recursion is clear to you all. So let's take start and node, right? Here, what does this start and node means? This start and node are actually these three values. Okay, these three values will always go together in query, in update, because we need to know na ki if I'm on a current segment tree, then I'm on which node of this tree, right? Okay, so this is the start, this is the end, and this is node. That is the index of the str, right? So let's build it. Let's build it fast. So basically, what I'll call is build left build. I'll call right build, right build, and let me fill the values. Okay. So guys, when calling the left build, build the segment in the left part, my range is divided into, let's say I have a range start and end. So what is the range for the left part? It is start to mid, right? And mid plus 1 to end, the right part, right? Because 0 to 7 with split into two parts, 0 to 3 and 4 to 7. So I need to calculate the mid, right? So let's take mid. So basically mid is what? Start plus end by 2. This will be the mid index. So I have to break my node into two parts, left to mid and mid plus 1 to right. Okay, so let's divide into two parts. So start to mid, right? And what will the value of the left build subtree on the left node? It will be 2 into node plus 1, as already explained to you, right? So for the right build, what I need to do is I'll start from mid plus 1, go till end, and 2 into node plus 2, right? So after this, I have completed the left build part and the right build part. The left and the right recursions have been called, they have been covered up, the answers have been filled. So what will be the answer for my current segment tree node? It will be sum of the left node plus the sum of the right node, right? I hope this is clear to you, because I've already explained this part. Here it will be equal to the left sum plus the right sum, and I have already filled the left sum because I have came back from the recursion. I already told you that we need a good recursion knowledge to understand the code of the segment tree, and a good IQ to understand what a segment tree and how it works. Okay, to code it, we need to know about recursion. So let me fill the base cases. What will the base case? The leaf nodes, right? So what the specialty about the leaf node? Its start and end are same. Start equals to end. Then it's the base case. I don't need to further go into the left and right now. So what I'll do is here is I'll just make this node segment tree node equals to a of start, because the start value, this and the index all are same, right? For all the nodes you can see. Okay, so for that segment tree node, what I'll fill is the simple value and I'll return. This was my base case, the leaf node case. Okay, so what we need to do other is we also need to okay, let me build this tree dot build, and I'll start this build from the root node. The root node contains the answer from 0 to n minus 1, right? And the root node's index value is 0. So I started a build from the root node and it is building my whole tree. And guys, here there will be one issue that I will access this array start value. So how will I access the array start value? I need to pass this array. So let's pass this array by reference. Okay. So let me just pass this array here. Let's check for errors if there are no errors. So the tree has been built. Okay. Now let me try to write this. Let me just print this for you. 4 into n, I less than 4 into n, and let me just print the array, the segment tree array that we built. This array. Okay. Cout tree dot sti. Right. So we can easily see we have got the right answers, because this is a maximum segment tree and I have made the segment tree of summation. Basically, initially the values that I have written, we have the same values over here. Right. So at 0 index we have the root node. Its left child is 16 and its right child is 17. Right. Remember, right? Here it was 17 and here it was 16. Okay. Here it is 1. Don't get confused. The array is different. 1, 5, 1, 10, 2, 3, 5 and 7. Right. Okay. Right. So the whole array length is 34. That is on the root node. The left part we have the summation of this length. The right part we have the summation of this length. Right. And furthermore, you can basically match these indexes with the values. I hope it's clear. Moving on further. Right. So let me just comment it out. Now let's try to write a query operation. Okay. Let's query. So int query. Let's start and let's write an end, because start and a node, this will go hand in hand. Right. Because start and a node for every is like it's a triplet that is fixed. It doesn't change for a node. It will always remain fixed. Right. So start and a node. Right. So let me just build this. So for query, what else do we need? I need L value, that is the left value of the query, and the right value of the query. We need these 5 things to query. Right. Okay. So now I'm making cases. No overlap case, as already explained to you. What is the condition of no overlap? Again, writing over here is, let's say I have a start and end. That means I am on a current node. And when will I get a no overlap? If my left to right is over here, right? If my left value of the query is greater than end value of a current node, right? Let me write it over here. If L is greater than end, or when will I get another overlap? If my left and right value are over here. Start and end is here and my left and right are here. So what I have here is, if R is less than start. Okay. So if R is less than start, so this is the condition for no overlap, because we are not having any overlap. That means the right value should be less than start, or the L value should be greater than end of a current segment tree node. So guys, for no overlap, we don't have to go into the subtree, right? And what we'll return is, we'll simply return 0, because we don't need the answer from this node, right? Now writing the complete overlap case. What will be the complete overlap case? For a segment tree node to completely lie inside L to R, start should be greater than equal to L and end should be less than equal to R, right? It's pretty simple. Start should be greater than equal to L and end should be less than equal to R. This is my complete overlap case, right? Okay. So when we have a complete overlap, again, for a complete overlap, we don't need to go in the subtree. We need this answer, right? So what I'll return simply st node, the answer at current segment tree node, right? Otherwise, what I have is, I have a partial overlap. If I don't get into these two cases, I'll go into a case called partial overlap case, right? So the partial overlap case will be, again, I just divide that case into two parts, left and right. I'll ask the answer from the left part and I'll ask the answer from the right part. I'll return the answer left plus right. Okay, so just let me write it. And plus start by 2. Let's ask the answer from the left part, left query. It will be equal to which, how much? Query, right? So for the left subtree, I'll have start to mid. The range will convert. L2R will remain same, and the node will be 2 into node plus 1, as already discussed. That is the left query. Now writing the right query. What will be the right query, guys? Mid plus 1 to end. Okay, so we have the right query that is going from mid plus 1 to end, means the right subtree will go from mid plus 1 to end. And after this, what I have is L2R will remain same and the node value will change into 2. Okay, so here I have done both the queries, the left query and the right query. Now what I need to return is return left plus right. Okay, simple. It's a simple query function, no overlap, complete overlap and partial overlap. And just let me comment it, left query and right query, RITST. I hope this is clear to you all. Right, returning the answer, that is the answer from the right left subtree and the answer from the right subtree. Okay, now let's query. Okay, let's see if it is correctly working or not. Tree dot query. So for query, what I send is starting root node, that is 0 to 0 and 0, and L comma R values. Okay, so let me just calculate the answer from 0 to 7. Let's take the answer from 0 to 7 first. Okay, and then we'll print it. See out. $34, right? Well and good. Now let's have a different query, 1 to 7. 33, well and good, right? Let's have a different query, like let's say 5 to 5, and 0, 1, 2, 3, 4, 5. What we'll have here is 3, well and good. I hope it is clear to you all. How are we trying to query from the segment tree? Okay, right. So I have built the segment tree, I have queried the segment tree, and now the last part is update function. Then we'll end this webinar. Let's update the segment tree. Okay, again guys, we'll start the update from the root node, and either we'll go on the left tree or we'll go the right tree, and if we reach a leaf node, we'll update the value and come back up, right? So starting the update part, again I'll have start, end and node. These three things are must, and these three things will go together. Okay, always these three things will go together. Okay, now let's say I have to index comma value. We at a particular index update to a value. Okay, right. So let me just query it. Oh, okay, let me just complete the function. So how do I update it? Again guys, now what I need to check is whether the current index, it is in the left subtree or it is in the right subtree, right? So what are the indexes in the left subtree? It is from start to mid. And what are the indexes from the right subtree? It is from mid plus 1 to end, right? So let's calculate mid. Mid equals to how much? Start plus end by 2. So if this index, if it is less than equal to mid, that means it will be in the left subtree, because it is less than equal to mid and it will be greater than equal to start, of course, right? Otherwise, if it is not less than equal to mid, then it will be in the right subtree. Okay, so what I'll just call is, I'll call update. For this, I need to update in the left subtree, start to mid, index will be passed as index only, and value will be passed as value only, and 2 into node plus 1. And for the right subtree, what I need to do is mid plus 1, 2, and like I'll just recur for the right subtree, na? I'm just making a path कि if it अगर वो छोटा है mid से तो I'll go on the left subtree, अगर वो बड़ा है mid से तो I'll go on the right subtree. I'm just making a path. Okay, go to left sub tree, otherwise go to right sub tree. Mid plus 1 and 2 into node plus 2. Okay, right, well and good. Now let me write the base case. So what will the base case over here? If again I reach the leaf node start equals to end, I have reached the leaf node. Basically start equals to end also equals to index, because we all know start and end for the leaf nodes are equal to their indexes, right? So what I'll do over here is I'll just update segment tree node to array index value. Again guys, I'm passing on this I am using this array index value. What I need to do is now, oh sorry, one issue over here. At this st node I need to change the value to a particular value, right? So I'll make just starting node equals to value and array at this index. Let's just update the array also to the particular value. Now it's good. Okay, so the value that needs to be updated, I have changed the segment tree node to that value, and I have updated the index of that array also to the value. And guys, I'm passing on the array, so let's just pass on the array by reference, because it doesn't take much time passing by reference, right? Okay, so basically I have written up the update function too. Now let us okay, one thing is left. See, when I have updated the left subtree or I have updated the right subtree, then I need to update the current node also, na, while coming back, right? Earlier we went down to the leaf, we changed the leaf, now we are coming back. So when we are coming back, we are over here coming back and updating, right? Because these functions are called above this. So let's update the current segment tree node. Okay, so how do we update the current segment tree node? Let me take this value and just paste it over here. So again, the segment tree node equals to segment tree 2 into node plus 1 plus segment tree 2 into node plus 2. I hope this is clear to you all, right? And after this, just return, because it's a void function. Okay, and it wasn't necessary to write return, because we can write return over here as well, but it's not necessary, right? So basically I built a structure segment tree, full segment tree, and I have written down the update operations and query operations. Okay, so guys, just let me update. Okay, it is a working code, don't worry. And for this, try to update the values yourself, try to write the code yourself. Okay, and I've coded the whole segment tree. This is a segment tree of summation. So guys, when I have a segment tree of summation, in the no overlap case, I have to pass on 0, because for the no overlap case, I want an answer that does not make any effect on my other answers, because it's a no overlap case. So if I make a segment tree of maximum value, then what I need to pass here is I have to pass some very minimum value, int minimum, right? So what are the changes that I need to do is, if I make a segment tree of maximum, when I'll query the left and right part, I just query on the left and right, and I'll return the maximum, right? And also I need to change here also for the same. I have to change them. I have to take for every node the maximum of the left subtree and the right subtree. I hope it is being clear to you all. Okay, so try writing the segment tree of maximum yourself, and let's finish this now. Let's finish the webinar now. Okay. Okay, so let me just send you a link for this code. So that you can use it in the future reference. Just a second. Oh. Save. Okay. So guys, this, let me comment it. This, I hope you got this, right? So this is the link for the current code that I wrote over here. You can use this code for future references, right? This is a generic segment tree now, because we have made this segment tree because we haven't initialized it already, right? We can use it in every test case because we have used a structure over here. There are various uses of structure, right? Let's say we are having various test cases, and in every test case we need to build a segment tree. Then instead of initializing it first, just make a structure in every test case and try to initialize it and build the segment tree. Okay, so guys, this is the code. Let's finish off this webinar. Actually, I've gone fast over this webinar because there is another webinar, first of all, and secondly, you can see this webinar again, right? So okay, so I hope I made this thing clear to you all, the segment tree and all, space complexity, time complexity, and everything. Okay, now let's it's the time to say goodbye. Okay, let's finish with this webinar, and you can generate the certificate on this link cb.lk/certi. Right, you can generate the certificate on this link. I've commented this link over here. Okay, fine. So just go on this link, click on this link, fill the form. They'll give you the certificate, right? Uh, I've done my job over here, that I've clearly explained you what is a segment tree, and you can also make the segment tree yourself. Okay, so thank you guys. Let's meet you in the next webinar. In the next webinar, I'll explain Fenwick tree, that is the binary index tree, and also I'll code it. Okay, so fine. It will accept the response. Don't worry, it will accept the responses. Just save that link right now and try after a little time. Don't worry, it will work. Okay, fine. So let's meet in the next webinar. Thank you.